Hi and a very good day. So in this video session, I will continue discuss topic under stochastic time series, which is stationary time series. Alright. So depending on the probabilistic characteristic of our stochastic process that I defined before, okay, we now may have what we call it as stationary time series. Okay, so stationary time series is actually the most fundamental theory behind the time series analysis and forecasting when we observe this time series as a stochastic process. Okay, because of what? We have an observation. Okay, basically this observation is our sample observation, and we want to make a statistical inference based on our observation. Okay, so when we're talking about statistical inference, okay, we must make some assumption about the structure, the probabilistic structure. Okay, the idea of stationary is okay, our time series is actually a sequence of observation. Okay, now we want our sequence of observation have the same behavior, so that it will so that the probabilistic character can hold over time. Okay, so basically we have two type of stationary, which is strictly stationary and weakly stationary. Okay, I will discuss strictly stationary first. Okay, so let's take a look at what are the definition of strictly stationary. In strictly stationary, the most important theory behind strictly stationary is will make an assumption of the joint distribution. Okay, suppose that we have this joint distribution of this series yt1, yt2, and up to ytn. Okay, and we want to and we have we have yt. Okay, it's actually yt is from the same series but at a different time point. As example, okay, yt at t minus 1, yt 2 minus 1, and so on. Okay, at lag 1. Okay, so for this strictly stationary to hold, we say that the joint distribution of this particular series is the same for all choices of time point and all choices of time lag. Okay, and as example here, okay, suppose that we have an observation, and then this observation we want to see whether our marginal distribution for yt and yt minus k okay, we want to make the assumption of our distribution for yt and yt minus k. Under strictly stationary, since that we say that the distribution is the same, we say that for all time period, okay, the mean, the expected is the mean, and the variance is constant for all time. Okay, that's strictly stationary. Okay, based on this mean and variance, okay, we can define the covariance. Okay, the covariance or the auto covariance is the variance between the two observations. Suppose that for this example, I have t and s. Okay, t and s. So because okay, the joint distribution is the same. Okay, when we have yt and ys, okay, the covariance of yt and ys is actually the same as the covariance of, okay, yt at lag k and ys at lag k for all t, s, and k. This is a definition of the theory behind strictly stationary. Okay, and the thing is, what I'm trying to stated here, okay, is at the end we see that the covariance between yt and ys, the variability of our these two observation is actually depends on the time difference, or the distance between these two period T and S, and not uh, on the actual times T and S. Okay, so basically that's the concept. Alright, based on covariant, okay, we can define the autocorrelation, okay, for strictly stationary. Okay, but of course it is actually hard to define the joint distribution for all of our sequence, our observation. So in most practical application, okay, rather than we assume our stochastic process is strictly stationary, we say that our stochastic process is weakly stationary. And for after this, when we talking about stationary, we refer to the assumption of weakly stationary. Okay, so let's take a look at what is weakly stationary. Okay, a stochastic process is said to be weakly or second order stationary if, okay, for the first characteristic, the mean function is constant over time. Next, the variance is constant and finite, which is, okay, the variance is less than infinity. Okay, the covariance between yt and yt at lag k is independent and of t, and only differentiate by the distance in time k. Okay, in weakly stationary, the thing that we are most concerned is about the covariance, and based on the covariance we can define the autocorrelation. Okay, so this autocorrelation is can become the the based on the autocorrelation we can say whether our time series is stationary or not. Okay, because a stationary time series is characterized by its time invariant, okay, mean variant and autocovariance. Alright, and basically the term stationary, again, I want to emphasize the term stationary after this will refer to this weakly stationary. Right, so I have some example here. Okay, when we plot a stationary time series, we can roughly see like this pattern where it have constant mean and variance, while if you want to measure the constant autocovariant, it can be detected using some other measure, as example autocorrelation function. Right, okay, so I think that's all for this video session. I will continue my discussion in the next video. Thank you for listening.